There's a mountain in Washington state that tourists photograph every single day. It sits on postcards, it sits on license plates. And underneath its calm, snow-covered peak, something happened last year that scientists had never recorded in the entire history of watching this volcano. Over 1,350 earthquakes in just 7 weeks. The largest earthquake swarm ever measured at this mountain. And most people driving through the towns below it never felt a thing. Here's what makes this story genuinely strange. This isn't officially America's most dangerous volcano because of how violently it could erupt. It's not even really about lava at all. It's about something sitting quietly on top of the mountain right now, something that could turn deadly without a single drop of molten rock ever reaching the surface. So why did the ground suddenly start shaking like never before? And why are the scientists watching this mountain more worried about ice than fire? The list that changes everything. To understand why this particular volcano keeps scientists up at night, you first need to understand how danger actually gets ranked. The U.S. Geological Survey maintains something called the National Volcanic Threat Assessment, a ranking of every active volcano in the country. Most people assume the most dangerous volcano must be the one that erupts most often. By that logic, Hawaii's Kilauea would win easily. It's been erupting on and off since December 2024, sending lava shooting hundreds of feet into the air. But erupting often isn't the same thing as being dangerous. Kilauea's lava usually moves slowly enough that people can watch it, track it, and get out of the way. The real ranking depends on something different entirely. How many people live close enough to actually get hurt, and how sudden that danger could arrive. By that measure, one volcano stands alone at the top of the list. Its icy summit is visible from downtown Seattle on a clear day. Mount Rainier, an icy time bomb. Mount Rainier rises just over 14,400 feet, the tallest volcanic mountain in the lower 48 states. But height isn't what makes it dangerous. What makes it dangerous is what's sitting on top of it. Rainier carries more glacier ice than any other mountain in the lower 48, somewhere around 26 named glaciers, covering more than 35 square miles in permanent snow and ice. Picture that as roughly 17,000 football fields buried under ice thick enough to swallow a house. Now here's the number that should genuinely worry you. Rainier holds roughly 8 times more glacier ice than a volcano called Nevado del Ruiz once carried in Colombia. In '95, that volcano erupted, melted its ice cap, and sent a wall of mud crashing down onto a town called Armero. More than 23,000 people died in minutes. Rainier is sitting on 8 times that much ice, and underneath all that frozen weight, the mountain has been quietly cooking itself for thousands of years. Solid rock. Turning into clay deep inside Rainier, hot magma has spent thousands of years heating underground. Water into steam. That superheated water doesn't just sit still, it moves upward through cracks in the rock. And as it travels, it slowly changes the mineral structure of everything around it. Strong volcanic stone becomes something closer to soft, crumbling clay. Scientists call this hydrothermal alteration. Think of it like leaving a spoon in a hot cup of tea for years instead of minutes. Nothing dramatic happens at first, but stretch that process out across millennia, and the rock itself stops being rock. Right now, today, large sections of Rainier's upper slopes are made of this weakened material, held in place mainly by its own frozen weight and plane gravity. Stack 35 square miles of heavy glacier ice directly on top of that, and you have something close to a natural time bomb, one that doesn't even need an eruption to go off. An earthquake could trigger it, a sudden heavy rainstorm could trigger it, a fast burst of glacier melt during an unusually hot summer could trigger it. Even a landslide with nothing to do with volcanic activity at all could send it crashing downhill. This has already happened before, roughly 500 years ago, in what geologists call the electron mud flow. No eruption, no lava, just weakened rock finally giving way, roaring downhill toward what's now the Puget Sound region. That single event is proof this mountain doesn't need to erupt to become one of the deadliest natural hazards in North America. The summer, the ground wouldn't stop shaking. Which brings us to why last summer matters so much. At 1:29 a.m. on July 8, 2025, monitoring instruments around Rainier began picking up earthquake after earthquake in a tight cluster. Under normal conditions, this mountain produces around 9 to 10 small earthquakes a month, its regular quiet heartbeat. Occasional short swarms happen once or twice a year, and scientists consider that completely ordinary. What started that morning was nothing like ordinary. At the busiest point, the Pacific Northwest Seismic Network recorded 41 located earthquakes in a single hour. By the time things finally settled down in late August, scientists had located more than 1,850 separate earthquakes with thousands more template-matching techniques. Researchers eventually identified roughly 8,800 distinct events total, organized into 48 repeating earthquake families. Compare that to the previous record. In 2009, scientists recorded around 1,000 small quakes over just 3 days, the strongest barely reaching magnitude 2.5. The 2025 swarm didn't just match that old record, it obliterated it in total events, in speed, and in duration, stretching across nearly 7 full weeks instead of 3 days. And while all of that was happening beneath the ground, life above it looked completely normal. Hikers kept climbing toward the summit, families kept driving through nearby towns. Almost nobody realized instruments buried deep in the earth were recording history in real time, the word that comes from Indonesia. It's worth slowing down on the actual word at the center of this entire story, because understanding it changes how you see everything that follows. Lahar comes from Indonesia, a country that has suffered some of the deadliest volcanic mudflow disasters in recorded history. People who have witnessed one describe it as wet concrete moving at highway speeds, a churning mixture of mud, water, rock, ash, splintered trees, and boulders the size of cars, all crashing downhill together as a single unstoppable mess. And here's the single most important fact most people get completely wrong about them. A lahar does not need an eruption to happen. It doesn't need lava. It doesn't need an explosion of any kind. All it needs is heat, water, and rock that has been weakened over time, sitting on a slope steep enough for gravity to eventually win. Rainier has all 3 of those ingredients, sitting directly on top of each other, whether or not this mountain ever produces another drop of lava in our lifetimes. Chasing the answer. Naturally, the question on everyone's mind was simple. Was the mountain about to erupt? Scientists at the USGS Cascades Volcano Observatory, working with the Pacific Northwest Seismic Network, pulled out every monitoring tool available to find out. First, they checked ground deformation using GPS stations, looking for any swelling that would suggest magma pushing toward the surface. Nothing. The mountain's shape hadn't changed at all. Then they checked infrasound sensors, instruments that detect extremely low sounds humans can't hear, the kind rockfalls or small explosions produce. Nothing unusual there either. Then came the boldest step. On August 4th, 2025, USGS gas geochemists partnered with the National Park Service to fly a helicopter directly over Rainier's summit craters, the first airborne volcanic gas survey conducted at this mountain in 27 years. Their goal was measuring the chemistry of gas escaping from the fumaroles, the steam vents near the crater. Here's why that mattered so much. If magma were genuinely rising, scientists would expect to see a spike in sulfur dioxide relative to other gases. Instead, the instruments detected water vapor and carbon dioxide, consistent with ordinary low-temperature hydrothermal activity. Sulfur dioxide, the telltale sign of rising magma, simply wasn't there. Every single tool pointed toward the same conclusion: water, not fire. The leading explanation scientists settled on is called hydrothermal fluid movement. That same superheated water system that's been slowly turning rock into clay for millennia appears to have surged through existing cracks and fault lines, acting almost like a lubricant, letting sections of rock slip against each other and release bursts of seismic energy. This kind of activity has happened at Rainier before. It had simply never happened at this scale. Throughout the entire swarm, Rainier's official alert level never moved from green, its normal everyday status. By August 25th, seismic activity had decayed back down to typical background levels, and USGS scientists confirmed the earthquake rate had returned to its usual rhythm of roughly 10 events a month. But here's the part worth sitting with. Scientists were careful to note that the hydrothermal processes behind the swarm might still be happening at levels too small to detect, meaning smaller bursts of activity could return in the months ahead. And a swarm this large, the biggest ever instrumentally recorded there, told researchers something valuable regardless of the outcome. Heat and fluid are actively moving through Rainier's underground plumbing system in ways scientists still don't fully understand, even after decades of study. The real danger was never the eruption. This is exactly where the story shifts away from earthquakes and toward what actually keeps volcano scientists awake at night. Rainier's glaciers have been shrinking for decades as regional temperatures climb, and in recent years that shrinking has accelerated sharply. Several named glaciers have already vanished entirely, no longer meeting the scientific definition of an active glacier at all. That melting water has to go somewhere, and increasingly it rushes downhill faster than the mountain's old drainage channels were ever built to handle, creating smaller debris flows that tear apart trails and wash out bridges most summers now. Downstream from all of this sit real towns. Pierce County officials estimate roughly 2.5 million people live across the river valleys that could potentially be touched by a Rainier lahar in some form. Narrow that down to the highest risk zones directly built on old lahar deposits, and estimates run between 80,000 and 150,000 people living in towns like Orting, Puyallup, Sumner, and Buckley. built directly inside mapped hazard zones. To understand the true scale of what these communities are quietly preparing for, geologists point to an event roughly 5,600 years ago called the Osceola Mudflow, the largest lahar at Rainier in the past 10,000 years. A massive section of weakened rock collapsed on the northeast side of the mountain, transforming into a lahar that traveled more than 60 miles, burying what are now populated valleys under a thick layer of volcanic debris, material some residents are living on top of today without ever knowing it. Scientists have identified at least a dozen major lahars reaching toward Puget Sound over the past 6,000 years. This is a repeating pattern, not a one-time fluke. And the fastest of these flows can travel faster than 60 miles an hour on the mountain's upper slopes, built to buy seconds. Because a lahar triggered by a sudden landslide could arrive with almost no warning at all, this region built one of the most advanced volcano hazard warning systems on Earth, specifically for this threat. It's called the Mount Rainier Lahar Detection and Warning System, first established in 1998 and expanded multiple times since. Acoustic flow monitors buried along the mountain's most historically active drainage paths detect the specific ground vibrations a lahar produces as it moves, instantly streaming data to emergency operations centers staffed around the clock. Confirmed signals trigger sirens placed throughout the Ovest, most vulnerable valleys, giving residents an unmistakable signal to move to higher ground immediately. The National Park Service has approved installing lahar detection equipment at 9 additional locations, specifically to catch landslide-triggered, no-notice lahars that wouldn't come with the buildup of a slow eruption. In this April, more than 20 schools across eastern Pierce County ran what's considered the largest volcano evacuation exercise in the world. Students and staff practicing exactly what to do if the siren for a mudflow ever sounds during a normal school day. Why so many different instruments matter. It's worth pausing on why scientists never rely on just one signal when a mountain like this starts acting up. An earthquake swarm alone doesn't tell the full story. Gas readings alone don't tell the full story. Ground deformation alone doesn't tell the full story. It's only when researchers layer every available signal on top of each other, like puzzle pieces, that a reliable picture actually forms. That's exactly why Rainier carries one of the densest volcano monitoring networks in the second for decades. GPS stations tracking the mountain's shape down to fractions of an inch, infrasound sensors listening for sounds no human ear could catch, and airborne gas surveys sampling the mountain's breath directly from a helicopter above the crater. None of that infrastructure exists by accident. Decades of quiet, uneventful monitoring built the baseline scientists needed to instantly recognize when something like the 2025 swarm was genuinely unusual, without years of boring, unremarkable data sitting in the background. Nobody could have said with any confidence that this swarm broke every previous record on the books. Where this actually leaves us, right now, sitting here in August 2026, Mount Rainier remains at its normal everyday alert level. There's no sign of magma rising toward the surface, no sign of an eruption on the way. The historic shaking from last summer has faded back into the mountain's usual quiet rhythm. But normal doesn't mean zero risk, and for this particular mountain, it never has. The danger here was never really about whether an eruption happens. It's about a slow, decades-long weakening of rock beneath the summit, carrying an enormous and increasingly unstable mass of glacier ice directly on top of it. What changed over the past year isn't the underlying danger. That's been documented for decades. What changed is how loudly the mountain reminded everyone that it's still alive, still shifting heat and fluid through a plumbing system nobody fully understands, directly beneath a glacier system melting faster than at almost any point in recorded history. The volcano that appears on Washington's license plates is also, quietly, the one carrying the single most dangerous lahar potential of any mountain in the country, not because it's explosive, simply because of exactly how much ice sits on exactly how much weakened rock, directly above, exactly how many people going about their ordinary lives below.